So in this difficult problem, we're given that c and d are positive integers, and m is the greatest common factor of c and d. And the question is, then m must be the greatest common factor of c, and which of the following? And we're given these 5 choices: c plus d, 2 plus d, cd, 2d, and d squared. Now, there are 2 ways we can do this. I'm going to first do it with examples, which is perfectly fine. You have to think of examples that would eliminate the ones, and you'd have to just be left with one choice. You may have to do a little bit of trial and error. So let's say if c is 6 and d is, say, 15. Their greatest common factor, m, is 3, because this is 3 times 2, this is 3 times 5. Then what I'm going to do is to look at if that's the case with these examples. So the first one would be 6 plus 15 is 21. The greatest common factor of 6 and 21 is still 3. So that's still in the contention. 2 plus d would be 2 plus 15, which is 17. Greatest common factor of 6 and 17 is 1. In fact, there's only one number that divides, so that b is out. The product would be 6 times 15 and 6 times 15. The greatest common factor is 6, not m. So that's also out. 2d would be 2 times 15, which is 30. The greatest common factor of c and 2d is now 6. 6 divides both of them. So d is also out. D squared would be 15 times 15, and 6 is 2 times 3. So that's still it's going to be 3, because we don't really have any other number that's common. So we're really left between these 2. I'm going to have to use another example. If c is 4, d is 2, the greatest common factor, m, is 2. And then I look at the first example, 4 plus 2 is 6. Greatest common factor between c plus d, 6 and 4, is still 2, so m is 2. So that one's still in contention. Now, e becomes, c is 4, d squared becomes 4. Now the greatest common factor, m, is 1. Sorry, I shouldn't say m, but just the greatest common divisor is 1. It's no longer m, which was 2 here. So we know e is out, we're left with a, and the answer is A. So this is one way of doing this problem, which is a little bit tedious, requires a little bit of trial and error, but the general approach also requires some work to go through these choices. And the approach there would be, if m is the greatest common factor, then c is the m times some integer, and d would be m times y. Now, x and y do not share any primes, because m is the greatest common factor of c and d. So x and y have no primes that are common. So if you look at choice A here, c plus d is going to become mx plus my. And if I factor in m, so I know that m is a common factor of c and c plus d. The question is it the greatest common factor? Well, we do know m divides both of these, so it really rests on, what about x plus y and x? Do they have any other common factors? So now, we know x and y have no common primes. So here, actually the greatest common divisor of x and x plus y, if they have no common prime factors, is 1. And the reason for that is, you can imagine if x is, say, 2 squared, 3 cubed, 7. And then y is, so x, I'm going to write it as a plus. Now, since x and y share no common primes, I'll have to pick y as some other primes. 11 squared, 5 cubed. Let's say we just pick that. Now, if I have to check whether 2, 3, or 7 is a common factor of these two. So we know 2, 3, and 7 would divide x. But here, if you divide x plus y by 2, 3, or 7, this piece is divisible by that, but this number isn't, so we'll have a remainder. So we know 2, 3, none of these primes can be a common divisor, and basically there's going to be no common prime number or powers of prime, even 2 square. None of those would divide both of these numbers. So the greatest common divisor of x plus y and x is 1, provided provided x and y do not share any primes. And the way we wrote this out, because m is the greatest common divisor, it contains all the common pieces that c and d share. And so that's the reason why c plus d and c must have m as the greatest common divisor. So I know it's a hard problem, but this is the other approach. So just to recap, the correct answer is A.